In this video, I'll be helping you with the ALEKS problem type called partial fraction decomposition with repeated linear factors. To start our decomposition, I need to make sure that the denominator is fully factored. And at a glance, I can see that I should factor out an x, leaving me with an x squared in the first term, a minus 4x in the second term, and a plus 4 in the last. Just bringing over that numerator. To continue factoring though, I notice that this is actually a perfect square trinomial, so I can factor this denominator further into x times x minus 2 quantity squared. Okay, and now that we have that denominator fully factored, the partial fraction decomposition would give us first an a over that first factor x. And then for this second factor, since it is degree 2, the decomposition says that I will have two partial fractions here. One that will be over x minus 2, we'll call that one b, plus a second one that would be over x minus 2 squared. And you can tell from this pattern that if I had an x minus 2 to the third on the left-hand side, I would need an x minus 2, an x minus 2 squared, and an x minus 2 to the third. But this is the form of our decomposition. So I've rewritten this to get started. As before, I'm going to multiply each of these terms by the lowest common denominator. So everything on the left is multiplied by x times x minus 2 squared. Each of these terms on the right are multiplied by x and x minus 2 squared. And the reason is that this is going to allow me to cancel all of these denominators. So on the left-hand side, everything cancels, leaving me with just an x squared plus 3x plus 12. On the right-hand side, the x's cancel, leaving me a times x minus 2 squared. And then one of these x minus 2's cancel, leaving me with bx times x minus 2. And then in our last term, the x minus 2 squareds cancel, leaving me with c times x. I can continue to simplify here on the right-hand side. Multiplying out this x minus 2 squared, we know that it's x squared minus 4x plus 4. And then multiplying the bx would give us a bx squared and then a minus 2bx. From here, it's not as easy to see values of x that will make terms cancel on the right-hand side. So instead, distributing this a, we have a times x squared. A times negative 4x is a negative 4ax. And a times a positive 4 is 4a. Bringing down these other terms, I can group together on the right-hand side all of the terms that have an x squared. So there's an a and a plus b, so a plus b x squared. And then looking at the x terms, I have 3. I have a negative 4a minus 2b plus c that are each being multiplied by x. And then for constants, I have just that plus 4a. From here, looking at the left-hand side and right-hand side, the coefficient in front of x squared is a plus b. On the right, the coefficient in front of x squared on the left is 1. So 1 equals a plus b. And then the coefficient in front of x on the right and the coefficient in front of x on the left must be equal. So 3 equals negative 4a minus 2b plus c. And then the constants, plus 1 and the 4a, and the constants 12 and the plus 4a must be equal. So 12 equals 4a. From here, we have a system of equations, and we can begin to solve. First, in the bottom, I can divide both sides by 4 and get a equals 3. Substituting that in to the first equation, I have 1 equals a, which is 3, plus b. I can solve for b and get negative 2 equals b. And then to find c, I can plug both of these values in for a and b. And I would have 3 on the left equals negative 4 times a, which we know is 3, minus 2 times b, which I know is negative 2, plus c. Solving for c, we simplify on the right to be negative 12 plus 4 plus c, or negative 8 plus c. Adding the 8 over, c is 11. We have found a, b, and c using this system of equations, 3, negative 2, and 11. So looking back to our partial fractions, a is 3, b is negative 2, and c is 11. So this is our partial fraction decomposition for this expression.